In this video, I'm going to show you how to use the cast diagram model to solve a trigonometric equation. So if you don't know what a cast diagram is yet, I recommend you go see a short video that I created, the origin of the cast diagram. Now for effective learning here, I would like to split the screen into steps and example. So the steps will be the procedure that will always work if you follow for any kind of trig equation. The second column here is for showing you how to execute the steps practically. The first step, whatever the trig equation is, you need to arrive at trig function some angle expression equals some number. So a trig can be anything, sine, cos, and tan. The angle in this case can be any kind of expression from theta, x, 2x, 3 theta, minus pi over 2. It can be any complicated function as long as there is a variable that you need to solve in there. And the number can be positive or negative or zero. It can be anything as long as there is a solution. So for example, if you are having sine of some expression equals something more than 1 or less than minus 1, there is no solution to that, and you should know that. But if it's a tangent, then there is always a solution. So for example, you might have a problem looking like, let's say sine x equals minus 0.2. So let's keep it simple first. Now, the function I have in the example here is already that form. Trig, which is sine, x is the angle, equals a number, which is negative 0.2. So we're good to go. Step 2 is simple. I call this finding the principal angle. And that is done by just doing an arc of the trig function of the positive value of the number on the right hand side. So in this case, the principal angle, I'm going to name it alpha, equals arc sine, because the function is sine, so we do arc sine, of the positive value of this. Yeah, so I'm going to take 0.2 instead. So let's find that value there. Arc sine of 0.2 from the calculator. So that's the principal angle. Step 3, we're going to use the cast diagram. Use cast diagram to find the angles. And this may be 1 or 2 or more answers depending on the domain. Now for simplicity, I'm going to make the domain in the range of x greater than 0 but less than 360. So number 3 has 2 sub-steps. First is that you need to figure out using the actual number, which is this number here, figure out what are the quadrants that would give sine function to be a negative value. So we just draw a little diagram. Now we want to look for the quadrants where sine is a negative value. So it's the bottom 2 quadrants. Well, that means when we draw the lines to find the angle, we draw these 2 lines. The point is that since we have found the principal angle, the alpha is actually the physical angle in here and here, measured closest to the x-axis, like that. Now this is the first step. The other step is where you need to figure out what angles these lines represent. The way we measure the angle is always from this initial line. If you subtend anti-clockwise, you're going to get a positive angle. If you subtend clockwise, you're going to get a negative angle. Now looking at the domain of this question, I made it simple because I made it positive first. So we're going to be subtending anti-clockwise, so we're going to be going this way rather than the other way. We go until we meet the first line, which is here, and that is the first answer that you need to get. The physical size of this angle seems to be a reflex angle. It is just 180 and add by another alpha. We already know that alpha is just 12.8. So this angle is 180 plus alpha degrees. X, which is the actual answer now, is going to be 180 plus 12.819. So that is one answer. And the other answer is just doing the same thing but go for the other line. Well, basically if you subtend fully for one period, you get 360. If you go back by 30 degrees, you're going to get 360 minus that alpha angle. So the other one is going to be 360 minus 12.819. Whatever the numbers are, what's more important here is the method. So that means there are 2 answers to this trig equation. And that is the first example. Let's look at another one. Now this example, cos of 2x minus 30 equals minus 0.2. As you can see, the angle expression is now a little more complicated than before. However, we have already arrived at the form, the first step, because cos is the trig function, angle is that whole thing, 2x minus 30. Of course, we need to find the x, we'll do that later, and the number is negative 0.2. So the second step is find the principal angle. So alpha is just arc cos 0.2. Again, we take the positive value to avoid confusion when doing the quadrants. Now in the third step here, before we figure out the angles in the quadrants, so you would need to modify the domain of the answer and necessary because in this case, the answer you are finding is the x. But when you solve using the cast diagram, you are solving for the whole angle expression, not just x. So the angles you are getting from the cast diagram will be the angle for 2x minus 30 first. That means we need to modify the new domain for 2x minus 30. Well, the easiest way to do that is just multiply 2 on every side here and minus 30. So that's going to give me a new domain of 2x minus 30. So that's going to be 2 times 180 is 360 minus 30 is 330. On the left side, it will be 0 minus 30, so it's minus 30 here. So that is the modified domain when we look at the quadrants. I'm just going to draw the quadrants. Cos of some angle giving you a negative value. Cos, we look at the x-axis. The two quadrants where x-axis is negative, x is negative here and x is negative here. That means we draw these two basic lines, this one and this one. The principal angle or alpha is just the physical angle from the x-axis. We're gonna subtend from the initial line again. Now this time we can go a little negative here. Let's try that first. So if you want to go from initial line, negative side, we're gonna go up to this to see the first answer. Well, that seems to be less than minus 30 degrees, right? It's minus something, almost minus 180. So this one is not gonna be the answer. Our only hope would be to go positive, like usual. So the positive angle, the first one, will be this one. Well, what is that angle there? So again, I told you that the answer will be for 2x minus 30 first. The first angle there is 180 minus alpha. 180 minus alpha. Again, I'm telling you that the angles we are solving from this cast diagram is going to be the angles for the whole expression, not just x. Well, the other one is then 180 plus alpha. That's the other one. So you could try keep subtending beyond one period, but because if you go any further to see the first line again, your angle will exceed 330 already. We're not including that. The only two answers here will be from 180 minus alpha and 180 plus alpha. The last step here is just simple. In case you have the angle expression a little more complicated than just a single variable. So the fourth step here will be to solve for the variable. Just solve for x. So I'm going to write here x equals 180 minus alpha. So 180 minus 87.181 plus 30 first and divided by 2. So basically I'm solving this equation here. So that will be the answer for just x, which is 61.41. And the other one doing the same thing, but instead we have 180 plus alpha. So I'm just going to change in the calculator here. 180 plus alpha, alpha being at cos 0.2 plus 30 divided by 2. I get 148.59. So those will be the two answers for this trig equation with the correct domain. What if we don't arrive at the first step yet? Let's say we have a problem like a quadratic sine squared x equals 1 over 2. Well, because this is not exactly trig of an angle equaling a number. It's a trig squared. So you need to make that a degree of 1, not 2, not 3. That means you need to square root on both sides. Square rooting on both sides would give you plus or minus 1 over root 2. That means we have two separate cases here. This one, sine x equals 1 over root 2. And the other one, sine x equals minus 1 over root 2. Now we arrived at the first step. So the second step is find the principal angle. The principal angle for both of them will be the same as arc sine 1 over root 2. And that is just 45 degrees. We get the principal angle for both cases. Now let's do step 3. Use the cast diagram. I'm going to do them all in one diagram. Let's draw the cast diagram. I'm going to do like that. Sine of some angle giving a positive value would be the top two quadrants. So we have this one and this one. Again, the physical size of the angles here and here are the same as the principal angle 45 degrees. What about the pink case? It's just kind of the same concept, but sine of some angle giving a negative value. The bottom two quadrants, where again the physical size of these will be alpha and alpha. So we are taking all the angles represented by these four lines. And again, let's keep it simple. So let's say x is from 0 to 360 again. this will be 45. This will be 180 minus 45. This will be 180 plus 45. And the last one will be 360 minus 45. X will just be 45. 180 minus 45 will be 135. 180 plus 45 will be 225. And 360 minus 45 will be 315. So that's it. Those are the answers for sine squared x equals a half in the domain of 0 less than x less than 360. If you're not that satisfied yet, let's take one more example. Don't go anywhere yet. One last example, I promise. So how about 2 sine x cos x equals sine x? And now this case, I'm going to make x in the range of 360 and minus 360. We haven't quite arrived at the trig angle number form yet, so we're going to do that first. If you are thinking about cancelling the sine x here, I wouldn't do that because that would omit the answers for sine x equals 0 out and you will lose marks for that. So what we do instead is we move the sine x on the right side to the same side and the other side being 0. And then we're going to factorize sine x out. We're going to get this. Because this is in the form of some value multiplied by another value equaling 0. That means this can be 0 or this can be 0. So we're going to have two cases here. So I'm going to write sine x being 0 or 2 cos x minus 1 being 0. Yeah, again, let's find the principal angle again. The principal angle for this one is basically just 0. So if you have 0 here, that means the cast diagram will look something like this line, which is the initial line itself, and the other line will be this line. So the first one is 0, and 0 is in the domain here. We don't need to modify the range because that's already x. The answer to the first one will be 0, and then you go to the next one being this line, which is 180, and you go more. Well, you're going to get 360, but 360 is not allowed because it's exclusive of 360 here, so we're not going to take it. But because the domain is extended to a negative 360, so you can sweep anti-clockwise to this. The physical size of that subtending is 180, but because we sweep clockwise, that means the angle will be minus 180 instead. And if we keep doing it, we're going to get minus 360, which is not included in the domain. So these will be just the answers for the first case. 0, 180, minus 180. Let's have a look at the other case. So here we are solving for cos x equals 1/2. If we find the principal angle for that, well, arc cos 1 over 2 happens to be 60 degrees. Now, cos of some angle giving you a positive value is the first and the fourth quadrants. This and this. Where again, this will be the alpha and this will be the alpha as well. So we're just going to subtend the angles for the answers. The first one is obvious. You need to get 60 already. And the other one will be, well, if you go to that line, you get 360 minus 60. X equals 60 and 300, right? And we're not done because, again, you need to consider the negative angles. So the negative angles, we go like that for the first answer, clockwise from the initial line. And then we can also do this one. Right? So that is basically a reflex angle of 360 minus 60 again, but this time you need to put a negative value because you are subtending clockwise. So it's just going to be minus 60 because this is for the first one right here. And the second one is that guy where the physical size is also 300, but then we put a negative sign. And those will be the four answers from 2 cos x minus 1 equals 0. So to summarize the answers for this trig equation, then x equals 0, 180 minus 180, 60, 300, minus 60, and minus 300. And as you can see, it is very easy to miss some answers here if you don't know how to execute these steps properly. So I would say you go use these steps to practice on other questions. If you find this video useful, why not give me a subscribe because there will be more tricks and techniques to come, and I will see you in the next one. Bye.